In this video, I'm going to go over pH of salt solutions and at the end do one quick calculation to show you how it's done. So a lot of this we have already done before. There's only one real difference when we are trying to determine the pH of a salt solution. So we know that a weak acid ionizes, reacts with H2O to produce its conjugate base and H3O+. So that's HF, a weak acid. So now what if we have a salt, NaF? Well, salts will ionize completely to produce their ions, in this case Na plus and F minus. And then once the salt is ionized and you know what the products are, then you have to decide, is one of the products a weak acid or a weak base? In other words, will one of the products react with water? In this case, we know that sodium, Na plus, is a spectator ion, which means it doesn't react with water, so it will just kind of hang out and do its thing and not result in an acidic or a basic solution. Whereas F minus, that's a weak base. So once we know that F minus is a weak base, then we can write out the chemical equation for how that weak base reacts with water, which is the last one down here. So F minus plus H2O in equilibrium with HF and OH minus. So that tells us that F minus is a weak base, and then from here all we have to do is do a weak base calculation as we've done previously. So this slide shows you the acid-base properties of salts, and the first row shows NaCl as the salt. So NaCl has the anion of a strong acid, Cl minus, and the cation of a strong base, Na plus. Right? So the anion of a strong acid, the strong acid in this case is HCl, the anion is Cl minus. The strong base, NaOH, the cation, Na. So when you have the anion of a strong acid and a cation of a strong base, you end up with a neutral salt. In the second example, that would ionize to produce NH4 plus and Cl minus. So we have the anion of a strong acid being Cl minus and the cation of a weak base. The weak base is actually NH3, but the cation of that is NH4 plus. So since NH4 plus is an acid, this is going to be an acidic salt. NaF, we have the cation of a strong base, Na plus, and the anion of a weak acid, F minus. Okay, so the weak acid in this case is HF. The anion of that is F minus. Na plus is a spectator ion, and F minus is the weak base, so this is going to be basic. And if we have a situation where the salt ionizes into both a weak acid and a weak base, such as NH4 plus and F minus, then we have to decide which of the NH4 plus or F minus is stronger. So in this case, we would compare the Ka of NH4 and the Kb of F minus. Whatever one is larger would be the one that ionizes the most and would control the pH, making it either basic or acidic. So once we know that the NaF breaks up into Na plus and F minus, then we would write the chemical equation for the equilibrium between F minus and water, fluoride and water, which would be this. Fluoride plus water produces HF and OH minus. The OH minus indicating that this is basic. Since it's basic, we would have to find Kb of the reaction. Okay, not Ka. We'd probably be given Ka, but we need to find Kb. And remember, you can find that using this equation here. Kw equals Ka times Kb. So if you're given Ka, you know that Kw is 1 times 10 to the minus 14. You can solve for Kb. And then after this, it's just a weak base problem that we've done previously. So I'm just going to go over a quick example, calculating the pH of a basic salt. So the question, calculate the pH of a 0.575 molar solution of sodium acetate. The Ka of that equals 1.8 times 10 to the minus 5. So the first step is to write out the equation that shows how the sodium acetate breaks up. Sodium acetate is NaCH3COO, and that's a solid because it's a salt, and that breaks up into Na plus CH3COO minus. Now again, we have to determine if either the Na plus or the CH3COO minus reacts with water. We know that Na plus is a spectator ion, so that's not going to react with water. It's not going to produce any H plus or OH minus. CH3COO minus, that's a weak base, so that's going to react with water, and it's going to accept a proton from water and then result in the production of OH minus. So now that we've identified that CH3COO-, the acetate anion, reacts with water, we can write out the equilibrium equation. So acetate plus water in equilibrium with acetic acid and OH-, and then we can set up our ice table. Okay, now we know that the concentration of CH3COO-, the acetate ion, is 0.575 molar, because when the salt breaks up in step 1, we know the concentration of that salt, but since the ionization is complete, meaning that all the sodium acetate reacts to produce sodium plus and acetate ion, we know that the concentration of the sodium acetate also has to equal the concentration of the acetate ion. So we know the concentration of the acetate anion, and we can fill out the ice table. The next step would be to find Kb. Since we have Ka, we know this is a weak base, so we have to find Kb. So using the equation from a couple slides ago, we can find Kb, and that equals 5.56 times 10 to the minus 10. So the next step is to fill out the equilibrium expression. So we have Kb equals the concentration of products over the concentrations of reactants, which ends up being x squared over 0.575 minus x. And since Kb is small, we can ignore that x. So if we solve for x, we end up getting 1.78 times 10 to the minus 5 molar. And again, that's going to be the concentration of OH-. So now what we can do is to find POH, so negative log of the concentration of OH-. That ends up being 4.74, and then the pH being 14 minus POH, and that equals 9.25. Okay, so determining the pH of a basic salt is mostly the same as finding the pH of a weak base. The only extra step we have here is step 1, and that is to determine what the ions are that are resulting from the salt dissolving in water, and then deciding which one of those is going to react with water. So is it going to be the anion, which would probably make it basic, or is it going to be the cation, which would make it acidic? So there's another example here. I'm not going to go through it, but I will give you the answer to this one so you can see if you can figure this one out. So the answer ends up being pH of 4.65. The process is very similar to what we just went through, except in this case it's slightly easier because this one ends up being an acidic salt, so we don't have to worry about finding Kb, right? We're already given Ka, so we can just immediately use the Ka value and find the pH from there. We don't have to worry about finding POH in this case. So the next slide is just a bunch of weak acids, weak bases, and a number of salts that are either neutral, acidic, or basic. I would suggest that you try to determine yourself what category each of those compounds falls into, and then you can look in the next slide after that to see if you're right. So that's all I have for this, and if you have any questions, please let me know.